All right, let's solve this logarithmic equation.
Check it!
That's right, boys. I need to check it after I get my answer because I have a domain restriction for the logarithm. Okay, the thing I'm taking the logarithm of cannot be a negative. You remember how we draw our logarithmic, we graph our logarithmic function. It looks like this, right? And do we have any logarithm back here in the negative? No, we don't. Okay, so our logarithm has to be positive. So first thing we're going to do to solve this, we're going to use one of our properties that's going to allow me to put these two things together. Okay, ultimate goal to get the x out of there, but I'm going to put them together under one log, and that is going to be this quotient rule here. If I have the two logs to the same base and I'm subtracting, I can put them together as one logarithm with the quotient. So let's rewrite this. It's going to be log base 4 of x plus 10 is my numerator, comes first. The one that I'm subtracting, the x minus 5, is my denominator. All right, and this equals just a regular old 2. Okay, now how do I solve this? How do I get these x's out of this? See, they're trapped in here in these parentheses. How do I get them out? And here it is. So this is the definition of a logarithm. Okay, I like to call it logarithm to exponent. See, if you have this x inside of the logarithm, you can get it out using this. And what you do, you take the little base, you make it a big base, and once you do that, these other two things will switch sides. Okay, that'll help you remember it. So let's go ahead and do it. My little base of 4 becomes my big base of 4. And then my other two things will switch sides. The 2 will come over here and become the exponent. And this x plus 10 over x minus 5 comes over here. All right, so what we have done is we have gotten the x out of the logarithm, but now we still need to solve it. Okay, I want to get this x from out of the denominator, and in order to do that, I am going to multiply both sides times x minus 5. That will get the x to cancel on the right-hand side to reduce. Now I have no more x's in the denominator. And on the other side, I'm going to multiply this times x minus 5. Okay, so here's what I have. 4 squared, what's 4 squared? That's 16. So I have x minus 5 times 16. Okay, and most math people are going to put that 16 out in the front. I'll leave it right there. Equals x plus 10. Let's distribute. Linear equation now. Distribute. I will get 16x minus 16 times 5. Is that 80, I think? Equals x plus 10. Distribute, combine like terms, variables to the same side. Minus 1x on both sides. So x minus x is gone. No more x's on the right. So I will have 15x minus 80 equals 10. And 2 more steps to solve for my x. I need a little more space, so I'm going to bring this right here. 15x minus 80 equals 10. Okay, let's get that grumpy x by himself. Let's get rid of the minus 80. So we're going to say plus 80 on both sides. I have 15x equals 10 plus 80 is 90. One more step to get this grumpy x by himself. Divide both sides by 15. And let's see. 15, 30, 45, 60, 75, 90. That's 6 times. X equals 6. Okay, now, don't forget.
Check it!
That's right, I have to check it. Let's make sure this doesn't give me a negative inside of a logarithm. So I'll take this 6, I'll bring it up here for that x, and I'll bring it up here for that x. So that would have given me the log of 6 plus 10, which is 16, so I'm good there. And this would have been 6 minus 5, which is 1, and I'm good there. Okay, so this answer works out. X equals 6.